So some of the conference organizers asked me to give my perspective on our strategy regarding EJB and CDI. So I have to say that what I'm going to say should be taken as my perspective, although I think it's generally shared by Bill Shannon, who is my fellow spec lead on the Java EE expert group. So I have to caution you that this, again, should not be taken as a commitment to future product directions by Oracle. And since the future of Java EE is largely determined through the JCP process, the decisions that our expert groups will take will obviously play a key role in determining the directions here. So I'd like to start with some background on these two technologies and how they have evolved. And then I'd like to compare their advantages and disadvantages, under what circumstances it's preferable to use one or the other. And then I'd like to turn to a discussion of how we have better aligned the two technologies and how we plan to continue this going forward. So to understand this whole issue, I think it's important to look at the history here. Work on EJB began almost 20 years ago, and at the time it was regarded as a very important step forward. It adopted some very good ideas from Microsoft's MTS, for example, the notion of container managed services, what we call container managed transactions, for example, that are specified declaratively. And these container managed services provided considerable ease of use over the services of lower level systems that were prevalent at the time, such as TP monitors. EJB 1.0 also had the notion of components, which was, again, a concept that was largely popularized in Microsoft's COM, as well as other component architectures at the time. And components back then were regarded as being coarse-grained objects that operated according to the contracts of the containers that they were maintained in. So this was the world in the late 90s. It's fairly different from what it is today. And again, I think it's important to emphasize this part of the history that EJB was seen as very much a big step forward in 1997, which is when I joined Sun's JavaSoft group. And at the time, it was a source of much excitement in the community. Now things have since changed. EJB 1.1, I think you can think of as the first real EJB. There were some changes between 1.0 and 1.1 that made 1.1 much more the evolutionary path of EJB to where it is today. And this EJB 1.1 was a key part of the J2EE 1.2 platform, the first Java EE platform. And I should say that back in EJB 1.1, there were two forms of components. There were session beans, and then there was a primitive form of entity bean, the first form of entity bean in EJB. These entity beans were not really adequate in terms of what you could do with them. So in EJB 2.0, we focused on improving, or so we thought, the entity bean model. But we were still guided by the notion of entity beans as coarse-grained components, coarse-grained business objects, rather than plain Java objects or POJOs. Nevertheless, we got a few things right. EJBQL, the query language, has stood the test of time, and it has evolved into what is now JPAQL. We basically took the old style EJB query language and used it as the basis for a query language for JPA. And then in this release, we also introduced the notion of message-driven beans. And message-driven beans were at the time the simplest EJB component. EJB 2.0 also introduced the notion of IAOP interoperability so that you can have interoperable invocations between containers of different vendors. We made a few simplifications, or a few additions, I should say, in EJB 2.1. Most notably support for web services. So a session bean can be a web service endpoint. And we added a timer service for timed notifications. Now, the theme of Java EE5 was ease of development. This is the point at which we looked at our Java EE architecture and said, how can we make it easier to use for people writing applications? What stands in the way? How can we exploit the new features that Java SE introduced, such as annotations? I think we achieved a great simplification with EJB 3.0, and this, in my view, is the first modern EJB. EJB 3.0 made heavy use of annotations. It introduced the notion of resource injection, which was adopted platform-wide. It took the old-style EJB home and EJB component interfaces, those heavyweight interfaces, and made them unnecessary by introducing simplified business interfaces. They were just plain old Java interfaces as you would naturally program with. It also added the Java Persistence API, which was, we saw as a simplification and improvement over the old-style entity beans. And it added interceptors. So lots of key improvements that have found their way for use in other parts of the platform. EJB 3.1 continued this path of simplification. It added the no interface view, so now you don't even need interfaces for your session beans, your local session beans. And it introduced support for asynchronous method invocation, a new singleton session bean type with container managed and bean managed concurrency, and EJB Lite, which provided a way for a simple EJB that could be used in the web profile. So at this point, we looked at the components in EJB, not in the narrow sense, but in the broad sense, such as interceptors and JPA, and we wanted to separate them out from the EJB specification and from the, in the case of JPA, from the EJB expert group so that they could be evolved on their own and made much more useful and available to other platform technologies. And in EJB 3.2, we started the process of shrinking EJB. We realized that EJB entity beans, the old style, were no longer the path towards the future because they were heavyweight components and they were superseded by the work that we had done with JPA. And so we made them optional and also support for JAX RPC, which had been superseded by JAX WS. So EJBs still support web service interfaces, but the expectation is that you're going to do this development using JAX WS instead of JAX RPC. So where are we today with EJB? In my view, EJBs are just POJOs. They have a long history, some of which we regard as not terribly desirable today, but I think it's important to have the perspective here of history. And the EJB container provides support for these POJOs. It provides services for ease of development. And this theme goes back all the way to the original EJB. Transactions, which can be declarative. You don't even, in the default case, need an annotation for container managed transactions. Container managed security, again, you have your choice of annotation-based declarative security or programmatic security. Thread management, synchronization for singletons, support for asynchronous methods. Timer service. So your timers can be either defined programmatically or you can apply a simple schedule annotation to specify when timed events should occur. And let's not forget injection, which was support initially for at-resource or at-EJB style injection. And on top of all that, the container provides services for integration with the outside world, with JMS for message-driven beans, with web services where EJBs can be web service endpoints, and of course for IIoP-based clients and services. So let's look now at CDI. The history of CDI is much shorter. CDI 1.0 was developed in the context of our work on Java EE6, so only a release and a bit ago in short term in history. Its original goal was to provide a glue layer between JSF and EJB. JSF is the leading web tier technology of the time, and EJB is the simplified and leading component architecture. So Gavin King, who was the originator of CDI, I should note, has been one of the key contributors to EJB 3.0 and 3.1, and also to JPA in those expert groups. And he was a strong supporter and advocate of EJB, hence the origin of CDI to support this. But CDI quickly evolved into something much more ambitious than a mere glue layer between other technologies. And it had some brilliant ideas. By leveraging the use of annotations to provide strong typing, it provided a form of dependency injection that went way beyond what we had with EJB and Java EE resource injection. It gave you typed injection points and a type-safe injection resolution based on annotations, including qualifiers. And it had stereotypes that even provided a layer of abstraction on top of these and that allowed you to bundle them. It also provided for scopes and for context of automatic bean lifecycle management. So it managed automatically, for example, if your bean should be scoped to a request, or scoped perhaps to the application, or some other scope. And it provided a rich SPI so that you could define your own scopes if the built-in scopes weren't adequate to you. Producer fields, and producer methods are a source of managed CDI beans that provides an extensibility mechanism so that you can use a producer to construct or to give you a bean that wasn't originally intended to be a bean. And I'll give you an example later on. Again, another source of being able to customize and expand upon the base CDI. It also introduced interceptor binding. So CDI supported the old style Java EE interceptors, where you would use the at interceptors annotation and then specify the classes that were the interceptors to be attached. But it gave you a level of abstraction beyond that, again, annotation-based and strongly typed for interceptor bindings and also for decorators. And it introduced an event and an observer mechanism, which you could think of as kind of a pub-sub capability. You register for particular events and you get called when those events occur. And on top of all of this, it has a rich SPI for portable extensions. So this was an extremely ambitious piece of work. And to sum it up, at the time, CDI was what I would loosely call a big bang event for the platform. It's a new programming model in a 1.0 release. CDI 1.1 made a number of improvements over CDI 1.0. In terms of scope, it was obviously nothing like CDI 1.0 in terms of what it introduced. Some of these were at our urging. We wanted to always enable CDI, not having to specify a beans.xml but to allow you to construct a bean archive without the beans XML just on the basis of what was contained. So the notion of implicit bean archives was introduced. We introduced the priority annotation, not just for CDI, but in a general way, which enabled CDI to provide a global ordering of interceptors or decorators or alternatives that didn't require a beans.xml. Again, another level of abstraction. And in Java EE7, we used CDI interceptors to provide an equivalent, or a better equivalent, I should say, for what we had in EJB with container managed transactions. So the interceptor itself basically gives you is a transactional interceptor that wraps around an invocation. We also added around construct interceptors to make the interceptor notion more general. And CDI continued with its enhancements to the SPI and portable extensions. So if we look at CDI today, managed bean POJOs are obviously central to it. The name qualifier gives you glue, as it were. It allows for direct use of CDI beans in JSF, actually in the expression language in general. And the container provides services. So among these services are type-safe injection, injection resolution, automatic lifecycle management with contexts, scopes, and the callbacks that are associated with these, an event firing service and event delivery to observer methods, alternative ways to configure beans through producers or alternatives, and an extensible model and a rich SPI. So we have these two technologies that from 10,000 meters up seem to have similar goals. They're targeting at POJOs, simple Java objects, and services that are delivered by a container. And yet they're different in some important ways. So what do you use when, and why? So what does CDI give you that EJB doesn't give you? This is pretty obvious from what I just said. It gives you an annotation-based programming model where injection resolution with type-safe injection is at the core of this model. This type safety with annotation basis continues to interceptors and decorators. And it provides automatic context management, scopes, conversations, and the scopes are extensible, events and observers, producers, and disposers. So you can think of this all as providing a higher level of abstraction. The context management and lifecycle management of CDI, I guess you would contrast that against what EJB has with remove and with pooling. Pooling is a little bit of a quirk because when you inject an EJB, you don't know if that EJB has been used before for some other invocation. It might have been stored in a pool, and unless you're careful, it might have data that remained from that invocation. CDI frees you from having to even think about this. Events and observers, as opposed to the more simple callbacks that we have with EJB. A built-in notion of conversations for which there is no counterpart in EJB. And an ability to program at what I'm going to call the meta level through the very rich CDI that allows you to extend CDI and to customize CDI. And EJB doesn't offer this either. So this seems kind of one-sided. What does EJB give you that CDI does not? Okay, so EJB gives you remote access. You can invoke EJBs from RMI or Corba. You can provide web service endpoints so that your EJBs can be directly invoked through a web service. It provides integration with JMS, so message-driven beans can directly service incoming JMS messages. It gives you a timer service, the ability to schedule timed events, asynchronous method invocation, which CDI currently doesn't have, although the CDI expert group is talking about asynchronously invoked observers right now. It gives you security, so integration with checking the credentials of the invoker, so declaratively with roles allowed or also programmatically. And through its history, JPA was designed originally with EJB in mind, and container managed extended persistence context, which are the EJB's way of maintaining conversational state within the context of a stateful session bean, are indeed a good convenience for doing exactly that. And these are not yet available in CDI. And it gives you singletons, where singletons support container managed concurrency or bean managed concurrency, and support locking accordingly. So what else does EJB have in terms of advantages? So EJB session beans are CDI managed beans. So they share the benefits of CDI when they're used within CDI. Stateless session beans have dependent scope. Stateful session beans can have any of the built-in scopes. Singletons can have application scope. Now, a thing to note here is that if you want this benefit, you have to program within the CDI world. So you need to use inject rather than EJB, the EJB injection annotation, to acquire your EJBs this way. Now, the converse is not true. CDI beans are not EJBs. But what we are doing is we are in the process of moving benefits of EJB into CDI and making those benefits more widely available, not just to CDI beans, but to other Java EE managed objects. So we call this process managed bean alignment. And this is a way of bridging the gap in Java EE. Now, Java EE 6 introduced the notion of managed beans, the annotation at managed bean, the Java EE annotation. And it had a managed bean specification document that was part of the Java EE 6 platform. What this attempted to do was to identify commonalities among different components as managed beans. So things that were common, plus that identified points where a particular quote-unquote component type could extend the basic managed bean model. In my view, and not everybody would share this, but in my view, the managed bean spec was largely theoretical. So while it outlined such commonalities, it didn't really define the APIs that might reflect this. But in Java EE 7, we began the process of making the concept of managed bean more concrete. And we sought to clarify how the features that were provided by the various component types and the services of the various Java EE containers could be better aligned. So it was this agenda that we called managed bean alignment, and it was an important theme of the Java EE 7 platform. So this matrix illustrates the state of the world for Java EE 6. I know it's hard to read. It's a lot of what we call eye candy, but I'll make these slides available so that you can look at it more closely later on. If you read down on the left, I've listed there the various Java EE managed object types, like CDI beans, session beans, message-driven beans, servlets, various listener classes, interceptor classes, and so on. If you read across, you see the various container services that are made available to these managed objects. So For example, CDI injection, Java EE resource injection, events, observers, timers. So the areas that have a Y in them or that are shaded indicate which features are available to which managed object types as of Java EE 6. So what we did was we provided to the Java EE 7 expert group 6 more variants of this matrix, showing how we could potentially better align these features and services across the various managed bean types. And some of these matrices were more theoretical than others, but the point was to stimulate the discussion as to what steps should we take to make our treatment of managed objects more consistent. So what did we do to address this? First of all, we, me and Bill in particular, didn't like the fact that in Java EE 6, you had to use an XML descriptor to enable CDI, the beans.xml descriptor. So our vision was that CDI was indeed a very key part of the platform, and its functionality should be available by default. The way we resolved this, and it was somewhat of a compromise, was through the idea of implicit bean archives. That is, any jar or WAR file that contained beans with CDI bean-defining annotations would be a bean archive, and that CDI would be enabled by default for such a bean archive. Now, bean-defining annotations are a little bit limiting. You have to apply these to your beans, including dependent, which in a beans.xml archive you don't really need to do. But this was a compromise that was requested so that CDI could have a path to optimization of the processing of these archives. Next, when CDI is enabled, we wanted that CDI injection would apply to all Java EE components. So that Java EE components would support both the EJB style, the Java EE style resource injection, as well as the strongly typed CDI injection. And we also added support for constructor injection as well to be consistent along those lines. CDI beans also support CDI injection, of course, and resource injection. We're having this interesting discussion right now in the platform expert group as to what extent CDI really does support resource injection. But CDI producers, producer methods, and producer fields can serve to transform what we regard as resource injection into CDI injection, making it strongly typed. So if you look at this example, this is just a code snippet that illustrates a producer field. Notice that we're using resource to specify the thing that's going to be accessed in Jindy with this Jindy global address, that CDI is going to inject where customer database is specified as a qualifier for a data source. So this gives you a way of transforming the more primitive resource injection to something that's more consistent with the CDI approach to injection. Another area of alignment has to do with interceptors. So CDI interceptor binding interceptors apply to all Java EE components when CDI is enabled. So EJBs then support EJB interceptors plus CDI binding interceptors. CDI beans from the 1.0 release also support the use of EJB interceptors. Now, you don't really see that because it's not the CDI style, but these are supported, as well as the CDI interceptor binding interceptors. And to make this consistent across Java EE components now also support both. So interceptors are a very powerful mechanism, and one of the things we did was to take CDI interceptors define interceptor binding annotation, and this was done in the course of our work on JTA 1.2, a revision to the JTA spec, to introduce JTA transactional interceptors. So the transaction type, here the default is required. This is just like the semantics of the EJB container managed transaction required attribute. And the other 5 EJB attribute types for transactions are also, those semantics are also captured as options for transactional interceptor transaction type values. But this provides more flexibility than what we had with EJB, because you can also specify within this annotation those exceptions that you want to have the interceptor, when the interceptor encounters a particular annotation, whether you want the interceptor to mark the transaction for rollback only or not. So rollback, with the rollback element here, you would specify those exceptions for which the transaction should be marked for rollback. Don't roll back on takes precedence, so it can override for a particular exception subtype this rollback behavior. So to be more concrete, if you look at this example for our shopping cart, we specified that we want an interceptor with required transaction attribute, namely if you don't have a transaction, the interceptor is going to start one. And we're saying that if you encounter a SQL exception, the transaction will be marked for rollback. But if that SQL exception has to be of the class SQL warning, we don't want the transaction to be marked for rollback. So this provides more flexibility and a cleaner mechanism than we had with EJB container managed transactions. We also leveraged CDI interceptors for bean validation. So in this example, valid order is being implemented through a CDI interceptor mechanism underneath the covers. And what this validation interceptor allows you to do, depending on how you code it, is 2 things. You can use it to provide cross-parameter constraint validation, and/or you can use it to validate the result of the method. So we're intercepting the invocation of this method for constraint validation. We also leverage CDI for the definition of scopes for Java EE objects. Transaction scope was defined within the JTA 1.2 work. It's used by JMS. Flow scope was defined within JSF 2.2. We had hoped to define a scope for WebSocket endpoints as well. We ran out of time in Java EE 7 to do that, but this is again a candidate piece of work for Java EE 8. So to come back to our matrix, what do things look like at the end of Java EE 7? This matrix captures in the light gray everything that you saw in the previous variant of the matrix. And in the kind of grayish blue color, I guess you'd call it that, I've highlighted what we did to better align the situation in Java EE 7. So in particular, note that we've defined how you can inject various managed objects into other objects with add-inject, and the more general use of interceptors and decorators, and not just CDI beans, but other Java EE components support constructor injection as well. Okay, so what then is our strategy for the future? So we want to continue the expanded use of extracting container services inspired by the work in EJB, which pioneered some of these, and make those services more widely available. So in Java EE7, well, we had container managed transactions that were implemented through interceptor bindings, which we specified in JTA. We'd like to do something similar along similar lines with container managed security. We'd like to provide authorization interceptors. And while EJB has the ability to have asynchronous invocation of components for incoming JMS messages, we'd like to extend that service to other component types as well. So if you came to my talk earlier today, I'm going to be repeating myself. If not, if so, please bear with me. But I wanted to cover this because this is an important feature that we will be adding in Java EE8. So we plan to provide security interceptors to provide authorization checks. And this you can think of as a more general and flexible approach than what we have with roles allowed in EJB or in servlet. So the idea is that such an interceptor would let you not only check that the role of the caller was a particular role, but would also give you the ability to access contextual information. And the intent here is that this would be accessed through, through expression language constructs. So in the first example, we're checking whether the caller has the manager role and whether the schedule, the contextual information with regard to schedules show that office hours are in effect. In the second example, we're also checking the role of the caller, but we're checking whether this caller has attributes such that the employee whose salary is going to be accessed is among the direct reports of the caller. And in the third, we're going beyond and accessing a repository of rule authorization rules to check whether the rule for report is being satisfied before we invoke the method display report. So this is a much more flexible approach than what we had with a very simple roles allowed mechanism. When we think about message-driven beans of EJB, our goal is to add a new API to allow other managed beans to be the recipients of asynchronous JMS message delivery. And part of the goal here is not just to be more flexible, but also to be more simple, to make it easier for the developer. So to remind you of what the world looks like today, EJB message-driven beans are saddled with a fair amount of metadata that is kind of ugly. You need to specify activation config properties for your message-driven beans. Part of the reason here is that when we designed message-driven beans, the intent was that they would not service only JMS, but more flexibly other messaging types. At the time, we were thinking of JAX-M, which XML messaging, which never really got off the ground. But some of the history here causes unnecessary complexity if we just focus on JMS. So again, this message-driven bean has to implement a JMS-specific message listener interface, which restricts you on the form of the method that's going to be invoked when this message comes in. So our proposal is that we want any Java EE bean to be a listener. So in this case, I have a CDI managed bean that I've annotated request scoped. We could potentially have an application scoped bean be the recipient of these messages. And we've annotated this method as a JMS listener. This annotation is quite simple. All you really need to specify here is the queue, the JMS queue, from which the messages are being extracted. And our message is going to be transactional. I'm applying a transactional interceptor. I can call this method anything. It needs to receive the message as an argument. But we could have other arguments here as well that were supplied through CDI injection. So you can supply contextual information as arguments to this, this method as well. You're not restricted as you were with EJB. So there are other areas of alignment we'd like to address. The JAX-RS spec has some clarifications to make with regard to support for CDI injection and parameter injection. We want to finish the work on WebSocket endpoints. And something I think would be very desirable, I'm not sure whether we will be able to do this in Java EE8 or it will need to go to Java EE9, is the extension of the EJB timer service in a more, again, in a more general way, and time notifications, and making them available to other bean types. Now, obviously, there is some remaining gaps. One of these gaps that I'd like to stress is that while CDI components can be injected as CDI managed beans, they can be injected with inject, Java EE components other than session beans lose their Java EE component properties. So more concretely, while you can inject a servlet instance into a managed bean, the instance that you inject will not be the same servlet instance that will be serving web requests, right? It's not the same component semantics. It's the same instance of the same class, but it's not behaving as you would expect a servlet to behave. Okay, so to sum up, we've made a lot of EJB features that were designed for ease of use, more broadly available through CDI mechanisms to other Java EE managed beans. So starting with Java EE6 and interceptors, Java EE7, we took the idea of container managed transactions, generalized them and improved them with transactional interceptors. In Java EE8, we intend to take container managed authorization, again, an idea from the EJB spec, make it more generally available through security interceptors, message-driven beans for the delivery of asynchronous delivery of JMS messages. We would like to have simplified messaging with other bean types. I've labeled the timer service and timed events for Java EE9. Again, I'd like to bring this in sooner, but it's not clear that we'll be able to fit that in. So, given all of that, what is the future of EJB? Now, part of EJB has become optional or may become optional. So EJB entity beans and EJB QL have obviously been superseded by JPA, and they were defined as optional in Java EE7. Likewise, support for JAX RPC, which was superseded by JAX WS. So one of the things we intend to propose to the platform expert group and the EJB expert group is whether we should take those old style EJB interfaces, the EJB component interface, the EJB home interface, the interfaces that were required to provide IAOP interoperability, and move those to the proposed optional state. The way you make something optional in the platform is a two-phase event. One expert group decides that something will be moved to proposed optional status. Proposed optional status doesn't mean that it is optional. It means that the follow-on expert group, so in this case we might be talking about Java EE9 or perhaps even some later expert group, makes the decision whether something should in fact truly be optional. And or it could defer to the decision to yet another expert group. So this optionality process is slow. It's intentionally slow because we want to be careful. People have investments in their Java EE app servers, and we don't want to perturb that. So it takes a full 2 platform release cycles for anything to be optional. But optional means that a vendor is not required to stop supporting that. A vendor can ignore the optionality and still provide the service according to the rules of the specification. And since Glassfish is the reference implementation, it will indeed always be supporting features that have been made optional. It needs to as the reference implementation. So what's the future of EJB? We've made important features more broadly available, and this is through the mechanisms of CDI. So will EJB still be relevant? Well, I think its future depends on several things, and again, we're looking far out in time. It depends on the future of the remaining features. So remote access, the timer service, whether we make that more broadly available or not. The value of component types for which there is no exact equivalent elsewhere, such as singletons, which have the nice at startup option, or you can express dependencies among singletons, and container managed concurrency. Asynchronous method invocations, and some of the tight integration with JPA, although we would hope to make some of those JPA features more broadly available. So finally, you folks get to play a role here. You get to influence this discussion. You get to influence the future of these technologies. And there are a number of ways you can do so. We have an Adopt a JSR program where JUGs traditionally have been participants in this program. They can choose to focus on a JSR or several JSRs and channel their collective feedback to those spec leads and expert groups. You can participate by tracking and discussing online in our users list the activities of an expert group. So you can receive all of the emails and you can discuss the ongoing issues either in the users list or on the issue trackers, the JIRAs. Our evangelists like to keep the community up to date on the emerging new features of these JSRs, and one of the best ways to track that is through the Aquarium blog. And then, of course, we have our reference implementation. So I'll leave you with those thoughts, and if you have ideas for what we should do, opinions, please give us your feedback. Thank you.